Welcome to the 8th episode of the Kern Competence podcast, a podcast about all things Kern and precision. Today I am joined by Arthur Turner. Arthur, welcome.
Hello, good to be here in National Oil.
Yes, Arthur, I think this is our first real guest segment. So far it's been people who work daily at this factory. You're not working daily in Eschenlohe, and I think everybody can directly hear it from your accent.
Yes, I'm Liverpool based in England and worked as an agent for Kern for nearly 28 years.
That is a long time. Just before setting up the podcast, I was telling you I was born in 91, so just 33 years of age, and you've been nearly working for Kern as an agent for longer than I am alive. That's very impressive. Let's go back a little bit further in history. Tell us a little bit about your background, where you come from.
Being based in Liverpool, when I left school at age 16, I tried to get an apprenticeship in an engineering company, and at that stage there was lots of companies offering apprenticeships. And I was lucky to get an apprenticeship with an organisation called Lucas, who were a big aerospace and electrical part manufacturer for UK industries. I did a 4-year apprenticeship and finished in the aerospace factory, where I was lucky enough to go into what we call a methods department, which was troubleshooting on the shop floor with either the production method, the cutting tools they had, or the machines they were trying to produce on to achieve the tolerances.
Back then, it wasn't really CNC machines, was it? I mean, you now have to state, I know how old you are, but you have to state in what year did you start your apprenticeship?
I started my apprenticeship in 1968. So I finished in 1972, and CNC wasn't around. NC was around, and you used paper tape or magnetic tape to control a machine, but that was not easy. If you made a mistake, it was a major disaster.
Did you learn how to program those NC machines in your apprenticeship? Was it part of it, or was it just wholly manual machining?
In the last year of my apprenticeship, yes, because you worked for 3 months in different segments of the business. So what we call methods or production planning or tool design or work study. You went around the different departments to get an appreciation of what you needed to do when you were actually in the production environment. It was good. It really was a fabulous apprenticeship. I would like to thank Lucas very much for that.
It sounds like a very good foundation, especially considering that, well, you had to do everything manually back then. Did it involve tool grinding as well in your apprenticeship? Because I couldn't imagine that you could just obviously you couldn't open a web page and just order a tool.
Correct. You did some tool grinding, mainly lathe tools or parting off tools, drills, less with reamers, and you didn't even think about form tools.
Okay. With reamers, you're already entering some precision stage there. And I mean, working for aerospace, even back in the 60s and 70s, this was one of the branches that back then pushed precision forward. Did you get any early appreciation for precision in your apprenticeship?
Very much so, because back in those days, and being based in England, we worked in inches, and if you were really, really good, you could achieve 1/1000th of an inch tolerance. Well, 1/1000th of an inch is 25 micron.
Yeah,
it's big by today's standards. If you were really, really good, they put you on the jig boarding department, and they work to a half thou, which is 12.5 micron. So the precision was there. I wouldn't say all the components had that sort of tolerance at that stage. So even in aerospace, you were talking 2, 3, 5 thou, which is big numbers in microns today.
Yes. How was metrology done back then? You obviously had a metrology department or something like that?
Yes, and they used slips and height gauges. There was no CMMs.
Yeah.
So to measure a bore, you'd have bore gauges.
Okay.
Yeah. With a no-go and a go at either end of the hand. So difficult to say, oh, that's such and such a size. But there was people in the factory who had that feeling for engineering, and if they could put a go into a bore, they'd tell you whether it was a thou or 2 thou bigger quite easily.
Okay.
But they had a lot of practice at it.
Yeah, this reminds me of a project I had a couple of 2 years ago. We were doing very, very fine threads in ceramics for a watch application, basically a main dial for watch. And the smallest thread we were milling in sintered silicon carbide was S0.4. And this was my first time ever encountering a 0.4 thread. And the thing with ceramic threads is you can't no-go gauge them. Because usually on a metal thread, well, you take the no-go gauge and you try to bring it in and it gets stuck. And on the ceramic, it will just like break and splinter and everything. So you can only go gauge them. But if you have a 0.4 millimeter thread, that's really, really tiny and you're not feeling a lot. And this project, luckily enough, was with a very good customer of ours. And they sent one of their very experienced watchmakers over. And I spent a day with him basically wiggling thread gauges in very small threads to get a feeling for what is an acceptable S.4 thread in ceramics.
Yeah. Well, you measure in millimeters, and quite often I will put a steel rule down and you look at what a millimeter is. Yeah. And then you start subdividing that up and it's wow.
Yeah.
Yeah.
Yeah, I mean, that's something that fascinates me all of the time. And I would say especially with the people at Kern who are not super technical, sometimes you mill something and the form error is like 4 or 5 microns. And they are like, oh, 5 microns, that's not very good. And I'm like, this is a 1/10 of a blonde hair. You just have to grasp that scale behind it, which is really weird. Okay, backtracking on topic, apprenticeship. 4 years, that sounds quite long. Is it still the case in the UK that you do 4 years of apprenticeship?
I think it varies between 3 and 4 years.
Okay.
But when I started, we did 2 years in an apprentice training school.
Mm-hmm.
And one of the key things that they did, because they were trying to develop young people, you had to get changed into a PE kit. Okay. Before 8 o'clock, before you were able to clock on and go outside. So when the 8 o'clock buzzer sounded, you were ready to do physical exercises. And it didn't matter whether it was the middle of the summer or it was the middle of the winter and there was snow on the ground. Every day you did this PE. And then you had to get a shower and then you got dressed and got ready to go into the training school and do the work. That was tough, but it was good fun.
Yeah, I can imagine. Quickly, for our listeners who are not familiar with the term, PE is physical education, right? So basically like a sports lesson, physics education, yeah. Wow, I can't imagine if we were to do this with our apprentices nowadays.
Within the Lucas organisation, they had training schools all around the UK, and they used to have competitions, so football, basketball, cross-country running, and then there was a sports day where they had a decathlon where they had 10 sports and they had a different apprentice doing that particular sport to see who was the champion apprentice school.
Okay.
So there was lots of activities where you competed against other apprentice schools such as Birmingham or Acton in London or Cwmbran in South Wales or Burnley. So it was very competitive and everybody was striving to do the best at that as well. Mm-hmm. Because if you were doing that, it meant you had a couple of days off work because you'd have to travel.
Okay, yeah, I can see the motivation behind that one.
Yes.
I have to say it's pretty fascinating. I didn't know about the details about your apprenticeship before, and I can see that some of the content, so for example, like going a couple of months into every department, learning every step along the way. This is something, for example, we still do nowadays at Kern. Our apprentices are sent for a couple of weeks with production, with the electronics department, with our contract manufacturing. The very good ones get a stint in the applications department, get to mill on a Kern machine. But I have to say, what you said, one of the goals was to develop the people as young adults, to make something out of them. I'm not sure whether there is so much of a focus on this nowadays.
Certainly not in the UK.
Yeah.
They'll do an apprenticeship and you might do milling and turning, but it is a regional training school. So in Liverpool there's a training school and it might take 10, 20 apprentices in a year and give them the basics, and then after 12 months is up they go back to their own company and they might be just on a lathe or they might just be on a milling machine. They're not getting the same sort of broad education as I was lucky to have.
Yeah, I think it's one of the downfalls of that heavy specialization you have nowadays. Also, if you go to university and study nowadays, I think back like 50 years ago, going to university was like a holistic approach to education. It was about learning a lot. And today everybody is super afraid of just like having a nice CV, of rushing through university, of finishing before their peers. I personally spent 7 years at university and I consider them to be a grand time of my life, and I took courses in languages and in philosophy and just like trying to get that whole education into me. And I think this is something we are missing nowadays a little bit, because we are rushing people through to get like workers, to get them specialized early on.
I would agree, because having developed into an employer in later life, we struggled taking staff on that were graduates in mechanical engineering, and basically they didn't know anything, and I was suitably shocked and disappointed that people that we were taking on with great CVs weren't very good.
Mm-hmm. I can imagine that. Okay, you finished your apprenticeship after 4 years. What did you do afterwards?
As I said before, we were lucky enough to be promoted onto what we call the methods department, mm-hmm. which sorted out how you made a component,
okay.
and the actual method that you made that component, because you were doing lots of different steps in a manual sequence. So an aircraft component could take 130 different operations.
Wow.
That today you put on a CNC milling machine or lathe and it does it in one. Mm-hmm. Then there were different operations, and you had to make sure that when you'd done one operation you could grip the components safely to do a subsequent operation.
Okay.
I'm breaking it down into that system over the years. While I was involved in one department or one segment of machining, automatically it got you into the grinding department or the jig boarding department, because if the component was going to go there after my department, it had to be right for them to manufacture correctly.
Okay.
So you learnt a lot about everything.
Yeah, I can imagine it's a very holistic approach to the whole process, every step, and also seeing that the small things like a correct setup matter a lot.
Yes, yeah, without doubt.
Okay, so you said you were aiming to go into that department. Did you?
It's interested me more than being on a drawing board as a designer for either tool design or component design, and it was sort of helped that back in 1971 Rolls-Royce hit major problems with fuel pumps and hydraulic pumps for Concorde, and the production environment in the factory I worked, they lost about 25% of the staff while I was an apprentice.
Okay.
And because I was an apprentice, I was still safe because the company had said, we will employ you till 1972.
Okay.
But it was sad to see all the people losing their jobs, and the company still having to continue. But eventually that created opportunities for the apprentices that were coming through.
Okay.
Because having suffered the downturn, because of what the company did, they then created an upturn. So then they were trying to take people on.
Okay. Well, so what did you do then after finishing?
After finishing, I say I was lucky to go into the methods department and sort out
Okay.
the.
How long did you work in the methods department?
6 years.
6 years. Okay.
Yeah.
Can you imagine a lot of very cool parts done back then?
There was a lot of parts, and there was a lot of learning, and we had a little office on the shop floor where there was 4 methods engineers, and they each looked after different departments, and a couple of the guys were a lot older than me. I was 21, 22, 23. Okay. Other guys were 57, 58, 59 with a lot of experience, and if you had a problem and you couldn't see the solution, you could go back to the office and say, hey, I've got this, I'm trying to do that, how do you think it could work? And they break it down into nice steps.
How open was that environment to innovation? Because I can imagine if you said they were a lot older, probably very set in their ways and they could help you, but when there was a problem that couldn't be solved by a known technique, how open to innovation were they?
I would think the guys were quite open, but they had a set format for solving the problems.
Okay.
Yeah. You went down a particular route and you had to tick off action part 1, part 2, part 3. And if you're doing that correctly, all of a sudden you'll get to the end and the component you're trying to make has been produced correctly.
Okay. So you stayed there for 6 years, and afterwards?
Afterwards, I was partially influenced that one of the responsibilities I had was dealing with sales engineers who were trying to sell the company cutting tools.
Okay.
So the household names of Sandvik and Kennametal were coming in and telling us about their tips for turning, or their tips for milling, or different variety of cutters. So I was interested in what they were doing. I was also influenced by one of my cousins who had gone on to sales but in a totally different environment, and listening to the problems that he faced or they faced when they were in front of customers, and that sort of grabbed my interest.
Okay.
So I was at one stage then looking to find my way into the future. Unfortunately enough, a machine tool company that we had their machines in our factory, so I was aware of the machines and what they could do, and more the operators who used those machines, how good they were.
Okay.
That I saw an advert for a sales position in the Northwest, and I thought, well, I'll try and get it. So I applied. I got an interview, and then my boss came down and said, this job that you've applied for, now I'd not told anybody that had applied for a job.
Okay.
He said, this job you've applied for, do you really, really want it? And I said, how do you know I've applied for a job? He said, don't worry, I know you've applied for a job. And evidently the company had spoken to the management of the company I worked at. What's this guy like?
Okay.
But I went for an interview, and the biggest shock I always remember, the managing director of the company said to me, oh, I suppose you go to Spain like everybody else for the holidays. And my answer was, no, never been to Spain. Now, bear in mind, this is 1977.
Yeah.
He said, well, where do you go? And I said, well, I've just been to Iceland. And from being fairly relaxed, he sat up straight and started paying attention to what I was saying.
Okay.
Because I was being different to everybody else. What did you do in Iceland? Why did you do it?
Okay.
How did you get there? And that was an interesting story. But I spent 3 weeks in a part of Iceland with a group of other guys surveying the terminal moraines at the end of a glacier.
Okay.
Now, if we'd have had an accident, it would have taken 24 hours for somebody to get to you and 24 hours for you to get back to civilization, because of the transport structures. Nobody could have just driven a car, say, from Reykjavik. You know, we were taken in a plane, a DC-3. We flew about 200 or 300 feet with the doors open, and it's like, wow. It was different. They put us down, kicked us out of the aircraft, and took off again.
Okay. I can imagine that is very different to like relaxing in Spain on the beach, what he was used to experiencing, and then you go to Iceland and have an adventure instead. What machine tool company was that? You didn't mention.
Can I mention it?
Of course.
It was Deckel.
Okay.
And Deckel were based in Munich.
Yes.
And they employed about 2,700 people just in the Munich area, or coming this way to Eschenlohe, at Wolfratshausen, Garretried.
Yes.
And they were a really nice company. But unfortunately, after about 13 years, Deckel had made inroads into CNC, made their own control system, and it didn't work.
Okay.
The customers didn't buy the machine, and the company got into big financial difficulties and closed the UK operation. Well, closed all their subsidiary companies, and literally everybody in the UK, and we employed 30 people, were made redundant.
Okay.
There was a small group that they tried to keep going, because the managing director of the company was then looking for agencies to keep this group of staff employed. But then I found the opportunity to set up my own business.
Okay.
Which is where Rainford Precision came in.
So now we are in the 90s, 1991.
1991, yeah, January 91.
Okay.
And it sounds good. Oh, set up your own company and can start selling engineering. But one of the difficulties was yes, you can say you're setting up, and then you've got to organise insurance, you've got to organise transport, you've got to find out who would want to employ you as an agent, and get all the processes in place, get a computer, get stationery. And after 6 weeks, I'd not visited a company to try and sell them anything. And I'm like, wow, this isn't easy. 1991 was a difficult year. But there was companies who I dealt with bought equipment that I had. Now, some of the names of the companies I worked for were System 3R on EDM tooling, Xiaomi on spark erosion and wire erosion, Micron on milling, Rome on work holding. But I also worked for a company called Speedfam, and they had a tool and cutter grinder. Well, I was used to the tool and cutter grinders they had because they'd just taken the agency on. But the likes of System 3R, you had electrodes and they'd sold them in boxes of 10 or 30, and I would carry the boxes in my boot and I'd just say to the customer, oh, by the way, I've got a box of 30 electrode holders in the car, do you want them? I can give you a discount because you don't have to pay postage. And they'd buy. And there were some companies that bought 3R equipment, and I know they didn't use it for 6 months. And at the end of the year, having seen them not using it, I said to them, why did you buy those tool holders then? And their reply to me was, we wanted you to succeed, and we wanted you to we wanted to help you, and this was the only way we could help. So they bought equipment that was only £100, £150, but it all contributed to Rainford Precision surviving in a very difficult financial time. I'm very grateful for that.
So in the beginning, Rainford Precision was mainly selling equipment for machines, not selling machines in the beginning.
No, as I say, we work for Micron on the milling machines, but they've now been taken over by GF, and the Micron name isn't public knowledge now, unless you're quite old. And also Xiaomi on spark erosion and wire erosion. But Xiaomi had a major competitor, AGI, and GF took over both companies, and you only see GF wire erosion machines, you don't see the name AGI or Xiaomi.
I think on the very old ones, I mean, we have in our apprentice department, we have an old Micron machine still, WF21. This machine is always my story why I tell people Heidenhain control is awesome, because I would guess that machine is probably as old as I am. It's a Heidenhain, I think 320 control, and it has like 4 lines of display. Our apprentices, they learn like Heidenhain programming on it, and it's really difficult if you're only seeing 4 lines of code to keep track of your program. And sometimes if they are working late and none of the teachers is there, and they see I'm still in the company, they come up to me and they ask me stuff about Heidenhain. And the surprising thing is, having never gotten an introduction to that machine, I can actually use that 30-year-old Micron machine. For me, this is a major argument for a Heidenhain control, because while the control itself got more powerful, the actual usage of the control has stayed the same. I think this makes it much easier to get skilled labor as well, because everybody can just operate any Heidenhain. Without doubt.
Heidenhain were unique in what they did, but what they did well. And became very, very popular with their early systems. So before the 300 series, they had a 155, which was very conversational. But it really gave you a good lead into programming, and it was shop floor orientated. You didn't need a programming department. And that was one of the key things on the success of Heidenhain. And they've built some tremendous control systems since then.
Yeah. Yeah, I'm getting the new TNC7 next week.
Right.
Next Monday they are updating my machine. I'm very excited for it. So far we've shown it at exhibitions, but I haven't really worked with it. I'm also missing the TNC7 training, so let's see how it handles. It's probably like the largest user interface change Heidenhain has ever done. So I'm really excited for that one. Yeah.
If you think back to the early Heidenhain days, where you literally input everything, now with the graphics and the display screen and it's touch screen and different things, it's so much easier.
Yeah.
In the early days, it was easy, but in actual fact, it was still difficult.
Yeah, I mean, just like I mentioned, just keeping track of a program code if you're only seeing 4 lines. I can display like a whole page of program code on my machine. It's very easy to keep track of like jumps in the program and everything there, or of your contour. But back then you didn't have that. Okay, backtracking to Rainford Precision, your own company you started in 1991. You said the first few years were a bit of a struggle, but you had very good support from some customers. When did that change and why did it change?
Part of it was the market conditions in the UK changed, but also people got used to seeing Arthur Turner as Rainford Precision.
Okay.
If I go backwards slightly, when I was at Deckel, people say, "Oh, you'll only be there 2 years," because sales engineers are only ever in a company for 2 years, then they move on. When Deckel UK actually closed, there was one sales engineer who had 14 years service. I had 13, another one had 12, another one had 11. Once you joined the company, it was a good company to work for, and everybody stayed.
Okay.
And a lot of my customers didn't know me as Arthur Turner. They knew me as Arthur Deckel. And it was funny. So one of the first things I had to do, I had a printed sheet produced with my photograph, and it read Arthur Turner, formerly from Deckel, and then a description of what we did, and that was something that we handed to customers to get them to stop thinking about Arthur Deckel and think about Arthur Turner or Rainford Precision. And yes, it's funny, but because I'd stayed at Deckel so long, and that wasn't the normal for that time of year, I could understand why people thought I was Arthur Deckel.
Okay. Yeah. So the market changed in the UK, and I think you were starting to get interested in the mid-90s in selling more German machines.
Always interested in having my own machines to be able to sell. And then I had a shock. On a Friday afternoon, Xiaomi rang me and said, "Sorry Arthur, but we've decided to go with our own sales team." Because at that stage they had 1 or 2 sales engineers but used agents all around the country, and the sales agents or the sales engineer backed up the sales agent, and they were changing their system, and they were just taking on sales engineers and working direct. So that was bad, and I thought all weekend, how am I going to cope? I've just lost one of the major accounts, and I'd been taking people on to help support the growth in what we were doing. And on the Monday morning I rang Micron and said, "Have you heard I've been let go by Xiaomi?" And they went, And I said, "What do you mean?" "Well, we're thinking about letting you and all the agents go as well." So over the weekend the two major machines that we sold,
Yeah.
we lost.
Oh.
And that was a shock to the system. But people like System 3R and Rome, on the tooling side, they said, oh, good, you've got more time to sell our products.
Okay.
And they gave certain responsibilities to me. Rome, for example, they used to send a sales engineer from London up to Ford Hale Wood every 2 weeks.
Okay.
And they said, if we stop doing that, will you go into Hale Wood every week?
Okay.
So while I was my own company, they actually paid for me to go and spend a day in Hale Wood every week.
Okay.
And go around all the sections, particularly in the Hale Wood had two sides, one where they made the cars and one where they made the transmissions. And the transmissions is where they used a lot of sophisticated chucks on lathes, gear grinders, cylindrical grinders, and you could go and have to spend the day solving problems. But it was good because it helped me learn more. It was a real good education. And then we also had Vauxhall Motors, who decided to set up their own engine plant in Ellesmere Port, which is literally just across the River Mersey, if you know the Liverpool area of the northwest of England. And they needed help on their machines, so there was a lot of work done for Rome. And it was a really, really good education on component manufacturing.
I can imagine.
I'm very grateful to people like Rome and 3R for the help they gave me in developing me. So.
Okay. And then at one point you discovered a small German company from Upper Bavaria.
Yes.
And I think everybody is longing to hear how that came to pass.
Again, it was interesting. I had quite a number of customers who made electrodes, and they were my customers because they're working through the System 3R manufacturing route. And the machines they made the electrodes on were quite big milling machines.
Okay.
And they were saying, we don't need a big milling machine because the electrodes are 25 mil, 30, 40 mil. We don't make big electrodes, we want to make small electrodes. And we're interested in finding small but accurate machines. And then we were coming up to EMO 97, which was held in Hanover. And I paid to go over and work on the System 3R and Rome stand, but also spend some time looking at the marketplace. And I discovered Kern, helped by the fact that one of my customers had also been doing the same, and they said, oh, this little red machine could be interesting. It's a nice size for what we want to do. So when I was at Hanover, I visited the red machine manufacturer, which happened to be Kern.
Okay.
It was interesting because I spoke to Mr. Kern. I didn't speak to anybody else on the stand.
Okay.
I spoke to Mr. Kern, and we spent most of the time, Mr. Kern, trying to find out how much German I could understand and how fluent I was in German. And while I could speak some German, I certainly wasn't fluent.
Okay.
I could eat, I could sleep, but getting into the technical side of German, I couldn't do that.
Okay.
So it was thanks, but we've made a note of your name and that's it.
Okay.
And then about 6 weeks later, I had a phone call from a gentleman called Burkhard Rota, who was the MD of Kern.
Okay.
Mr. Kern was the owner,
Mm-hmm.
and he employed Burkhardt as MD. And this gentleman rang up late one night, and I said, Arthur Turner, and he said, Mr. Turner, I believe you know what a micron is. And that was the start of a beautiful relationship with Kern.
Okay.
He asked me questions, I answered. We agreed that he would send me some brochures, because in theory I had potential
Mm-hmm.
for his size machine. The brochures arrived. I took them to customers. And one customer I took the brochure to on a Thursday rang me on the Friday and said, forgot to tell you, we're going to Germany on Monday. Can we visit Kern?
Okay.
But this was just after lunch on a Friday.
Okay, yeah, and no one is working in Upper Bavaria after lunch on a Friday.
Nobody was answering a phone, and you used phones or you used fax messages.
Yeah.
So there was no reply to fax messages. We didn't have mobile phones.
Yeah.
We couldn't send text messages like today, where you just send a text message to somebody and say, ring me, or I want to do this,
Mm-hmm.
and he's got the weekend to think about it. So all weekend I was panicking that I've got a customer in Germany,
Mm-hmm.
and he's going to turn up and they're not going to be prepared to welcome him. So first thing on the Monday morning, I rang Kern, and Mr. Rota said, oh, don't worry, if your customer comes here, we will look after him.
Okay.
And the stress and strains in my body just ebbed away. He's going to be looked after, fabulous.
Okay.
The customer had come to Germany not just to see Kern, he was going to see his customers.
Okay.
So he was away for the week, and I went to see him the following week, and he said, it's really interesting, possibly we could see me, Mr. Rota. So we arranged for Burkhardt to come over to England. Now the customer was in Stockport, so only 5-10 miles from Manchester Airport.
Okay.
So really handy for the airport. And Mr. Rota landed about 2-3 o'clock in the afternoon. We went to the customers, and while we were there, Mr. Rota never spoke once about accuracy.
Okay.
He always spoke about finesse, and he showed sample parts,
Mm-hmm.
difficult parts that had been milled, but with very fine wall sections and difficult materials.
Mm-hmm.
But I always remember he never spoke about accuracy.
Okay.
And the customer, before we finished the meeting, gave him an order for an HSPC 2522
Okay.
worth about 125,000 Deutschmark.
Mm-hmm.
Yeah. And I'm shocked. I'm like, wow, that's fantastic. So we'd arranged for Mr. Rota to come to near Rainford, stay in a hotel. The following morning, I took him to my office so we could talk about his products with the people that we employed.
Mm-hmm.
And it was all, wow, this is good, this is different.
Mm-hmm.
And then we went to see another Manchester who was in the north of, the customer was in the north of Manchester. Went to see him, and Mr. Rota just went through what he had to say, showed him the samples, and by 12:30 we had another order for 125,000. I was like, wow. And we came out, and he said, never sold 2 machines in such a short period of time without doing a lot of technical work beforehand. But the one thing he did was he really gave the customers confidence that they could achieve what they needed to achieve. After that, the customers again, both sets of customers visited Kern and took people with them from the shop floor, the milling operators, and they came back, oh, really good, we can do this, we can do that. And that was the introduction. The 2 machines were delivered April, May in 1998.
Okay.
And that was the start of a very successful relationship with Kern, being different but being better than the competition.
Yeah. Were they the first Kern machines in the UK? Or was there some imported before?
There was one that had been imported, had been sold to Sandvik Coromant in Sweden.
Mm-hmm.
But unknown to Kern at that stage, the machine had gone to Sweden, but then they'd shipped it to a factory in Wolverhampton.
Okay.
So that was actually the first Kern.
Mm-hmm.
But it wasn't public knowledge that it was in Wolverhampton. It was only afterwards, when I think people from Kern were talking to Sandvik about, we've got these machines in England. And they said, oh, your MMT? Was it MMT? It was a tabletop machine. Was in Wolverhampton.
Okay.
Yeah.
I mean, I get that it was very surprising for Booker to see that 2 machines are sold in like 2 subsequent days, especially with a new sales agent. But I mean, Mr. Kern didn't really want to take you on as an agent, but he was still the owner back then. And I'm guessing you visited Kern shortly afterwards as well. Can you tell us a little bit more about like what was Mr. Kern like?
Mr. Kern was a very nice gentleman. I think in my Liverpool terms, I would put him down as a true Bavarian.
Okay.
And I could understand where he was coming from. I didn't have any problems with his desire for me to speak more German. And to be fair, at that stage, I'd then started learning more German.
Okay.
Because if I was going to come to Germany and I was going to bring customers to Germany, it was important for me to be able to speak the language.
Mm-hmm.
But we also were working at that stage. We'd worked for a company called Speed Farm selling a tool grinder. And the tool grinder had left Speed Farm, and then because I used to work for Deckel previously, then said, will you sell our tool grinders?
Mm-hmm.
And they're based in Valheim, which is only 20 kilometres from Eschen-Lohe. And only a few people there spoke English. But both Kern and Michael Deckel, over the next few years, were actually holding English language courses in their companies. Mm. So while I was trying to learn German, all my colleagues were trying to learn English. So when we had a phone conversation, they were wanting to speak English, and you got drowned out.
Okay.
Yeah. Everybody was wanting to speak English, and now you come to Kern and everybody speaks English.
Yeah.
Yeah.
I mean, it has changed a lot in the past 30 years in Germany. They started teaching English earlier and earlier in school, and now I think at Kern you can go up to anyone and speak to them in English, which is also nice.
Well, a lot of the people over here speak English better than what I do. I'm from Liverpool and I'm proud of it.
Yeah, very good. Okay, so you had the first 2 machines in the UK, and they were delivered in 1998. What was Kern back then? Like, were people instantly happy with the machines?
My customers, yes, because getting a Kern was different, because we had a 42,000 RPM spindle, so we could machine very, very quickly.
I'm guessing the standard speed for a milling machine back then was like 8,000 or 10,000 RPM maybe?
If we pushed it, 10,000. So quite slow. And if you're using a small diameter cutter, not an ideal speed to be running at.
Yes.
And so therefore the Kern with the higher speed spindle meant the tool makers had to learn how to use the tools, and therefore machine quicker.
Okay.
But also took care to machine accurately. And people would say to me when at subsequent potential sales, "Oh, who should we put on it? The best miller is so and so," and I'd go, "Don't want the best miller. Want a person with the correct attitude that'll want to learn and make it work. If the guy thinks he's the best, then he might want to make it work." And in quite a number of companies where we had Kern sales, they put one guy on it, he'd last 3 months, and he'd be the best milling machine operator in the company. Then they'd put another guy on who wasn't as good a miller, but had a more positive attitude and wanted to make it work and make it successful. And all of a sudden that guy, his standing within the company went right through the roof. He became the best miller. And it wasn't because he was good at the start, but it was because he had a positive attitude and wanted to make it work. And some of the operators I've known over the years have been absolutely fabulous. And they'd say to me, "Oh, Arthur, come and have a look at what we've done." And they're really, really proud at the dimensions or the tolerances they've maintained or the surface finishes they've achieved. And it gives me a really good feeling that they're enjoying work. Because if you go to work and you don't like it, it's hard. If you go to work and you're enjoying it, well, I'll say you'll stay later. My wife will testify. I've worked late at night. If I wasn't enjoying what I was doing, you wouldn't do it. You know, you've got to move things forward. And Kern gave such an impetus to people enjoying themselves. It was good when you went and you'd speak to the operators. And I'd visit the companies and I wouldn't necessarily want to speak to the management. I'd want to speak to the operators and make sure they're happy and they understood what they knew, what they were doing, did they need any help, and help them progress, because they were key to subsequent sales.
I mean, this is always something I found with our machines, that it's such a nice environment to work on. I mean, I spent the majority of my work week, I actually spent the whole work week in front of my machine. And it is an actually pretty pleasant environment to work at. The machines are, for a milling machine, relatively quiet. They are relatively clean and tidy because the enclosure is well made. And I know back then with HSPC it was even more of a case. They were even more quiet than nowadays because they didn't have the whole power. It's really different to like an iron hogging machine where you are super dirty all day and it's hard work. And then of course you start dreaming about what that machine can do. And that when you said that the operators were showing you parts and were proud of the parts they were doing, this is also something I see all the time with our customers. When I visit a customer, I don't do a lot of customer visits, but when I do, they are nearly taking me by the hand and showing me, look, this is the part I made and it looks fabulous. And I think this is something really interesting about Kern machines, and I don't see that a lot with other machines.
No. As a sales agent, it gives me a lot of satisfaction to see people enjoying what they're doing. That's important, because if they're saying this machine's good and it does this or it does that, the customer then potentially is going to be interested in a second machine or a third machine. If the operator says this is a load of rubbish, you won't buy another one.
Yeah.
So it's important that we look after the operators as best we can and give them a good feeling. And the people who are key to this are the designers at Kern. Some of the features that they put on machines and the way the machines can operate, you can see the operators gaining benefit. And it's not hard work. So.
Well, I mean, it's also, I would say, easy for you to say because you were able to support your customers so well because you have that technical background. We have a couple of like sales agencies in markets we don't really frequent a lot, and we don't sell any machines over there because mostly they have no technical background. They have a couple of our brochures. And I would say you are very special in the regard that in the UK and Ireland, which is an important market for us, we still have Rainford Precision as a sales agency because usually, like all other markets, we have our own people sitting there. And I would say this is because you have so much technical background, also by selling tools, of course, and knowing about the process, that always you were able to support the operator.
Yes. The cutting tools came after joining Kern, and a few customers were saying, "Oh, we want to do this particular function, or we need to machine this type of company, this type of components in this material." And you'd look on the marketplace, and it'd be difficult to find the correct products. Because back in the early 2000s, the number of people that made micro cutting tools was like, you struggled to find them. We were fortunate that we were introduced to Union Tool, but at that stage they were setting up their own subsidiary in the UK.
Okay.
But within 12 months of Rainford doing work with Union Tool, they closed the UK operation, and Rainford became a main agent for them.
Okay.
And one of the first things that we did was we took into stock every drill from 0.1 up to 3 millimeters diameter, and that was the range of drills Union Tool made. Under 2 millimeters diameter, the drill sizes went up in 10 micron increments.
Okay.
And we had every one in stock. Some of them we had 10, others we only had 2 or 3. But if a customer rang and said, "Have you got?" the answer was yes.
Okay.
So we could give a positive reply, we can ship them today. Not we've got to wait a week for them to come from Switzerland or Japan or whatever. And that gave further impetus to what we were doing with Kern, because we could go and visit a customer, and if the operator was saying, "Oh, we've got this job to do," "Oh, well, we've got a tool that's the right size, it's got the right flute length, the right number of teeth, this is the speed you want to use, this is the feed rate you want to use." So we've already told him how to do the job. And so automatically he would then order our cutting tools. So while we were visiting the Kern customer to sell another Kern, we actually sold them cutting tools as well.
Okay.
So they worked very much hand in hand. And if you see the product range that we have today, I would say we are still the market leaders in micro machining in the UK and Ireland. We do have competition on the cutting tools because more and more companies have started manufacturing micro cutting tools, but some of them micro starts at 0.5. Well, now we go to 8 micron diameter end mills and drills. So 0.5 is big.
Yeah.
You know, just No, I wouldn't even consider it now.
I mean, I usually tell people when they are like, no one except you guys at Kern needs this. For example, software errors in CAM software or some functionality in the control. And sometimes those suppliers of us, they are plucking us off and they are like, no one except Kern needs this. And I always tell them, well, this is right now. Right now, it's a current problem. No one needs something like this. But in 10 years, everybody is going to be struggling with it. And, well, look at it. I think like 15 years ago, Kern drilled through a hair with a 50-micron drill. Back then, it was a super small drill. Now it's like standard tool room size. Not standard tool room size, but you can go to, for example, Hoffmann, and you can buy a 0.05 millimeter tool at Hoffmann, which you couldn't imagine back then.
Yeah. But that example you give there was a UK application.
Okay.
Because I had a customer who wanted to drill micro holes for an inkjet printer.
Okay.
Bear in mind, this is 20 years ago, so we're really pushing boundaries of manufacturing then. And we couldn't find anybody that made a drill below 0.5. Below 50 microns.
Okay.
And then I went to an exhibition in Germany. I was with Burkhardt Rotor, and we were having a look round, and we found a company that did 30 micron drills. And he went up to them and said, "What's delivery on a 30 micron drill?" And they said, "A week." And he gave them an order there and then. The company shipped the drills to Kern, and then that evening at the exhibition it was, "We've ordered these drills, how are we going to demonstrate them?"
Yeah.
And this is where the hole in the hair came about. They took the hair off his secretary. They made a dimple in an aluminium block. They then stretched the hair and superglued it to clamp it, used an optical microscope to line the spindle up, took the microscope out of the spindle and put a 30 micron drill in, and then they drilled holes in the hair. Without burning the hair, which was a key point. And then the people within Kern, everybody was amazed that they'd gone and done this machining, and it's fabulous. And I think you have photographs here where Maxim Motors had said, "Oh, can we borrow it?" And they've actually made photographs, enlarged photographs, because they were the ones that supplied the motors to the machines. And the photographs that Maxim Motors did were fabulous.
Yeah, I think they put like one of their like winding wires, which was, I think it was like 20 microns. They put it through the hole and then took a shot of it. That's the famous shot. You do know, you did quite some damage with that project, because 15 years later, one of my first projects at Kern was to engrave a hair. And I basically went into exactly the same struggles you guys went back there. The very first try, it was just burning up. Something I discovered, and I don't think you discovered in drilling, is you need different feeds and speeds for milling the outside of the hair and for milling the core of the hair. Because like the fiber on the outside of the hair is tougher, and you need different cutting speeds than for the inside, otherwise it burns up. Which I to this day count as my most specialized knowledge of feeds and speeds on how to engrave hair.
Well, going backwards to when I was employed in the aerospace industry, I had to drill 10,000 holes, which is 250 micron, in cobalt alloy, and we were fortunate that we had a machine that did 40,000 RPM.
Okay.
And you went through all the books and you calculated the revolutions per minute, and 40,000 wasn't fast enough.
Okay.
But we said we'd give it a go. But what the books didn't say is that you needed to have a controlled feed per revolution. And the machine that we had at 40,000 RPM was a manual operation.
Okay.
It was a turret where the operator manually rotated it to drill the hole. So we kept drilling, kept breaking drills, and we could break 3 drills to produce one component.
Okay.
Then I left the company and I started working for Deckel, and I went to another company to sell them a Deckel, and they were explaining what they did, and they made paint and chemical spraying equipment.
Okay.
And they drilled 10 thou diameter holes, 250 micron, easily.
Okay.
And, well, how do you do that without breaking drills? We don't run them fast.
Okay.
So whereas we were trying to drill at 40,000 RPM, we finished up at something like 4,000. And instead of being on this manually controlled machine, we put it on another machine where we control the feed per rev. And literally the first time of asking, we did 5 holes with 1 drill. So automatically we'd made a big saving, not only in drill breakages, scrap components, but also time to actually manufacture the parts. And that changed my thinking on how to drill small holes. And we could go to customers. We've got one customer who drills micro holes, and he does 400 in an aluminium plate, and he'd break drills like there's no tomorrow. And we showed him how to drill, and we only used 8,000 RPM for what he was doing, and he'd do 400 holes. And he had a tight tolerance, so we didn't use reamers, we just used the drill. And he's been doing that now for just under 20 years.
Okay.
Yeah.
On a Kern machine?
No.
What a pity.
Well,
probably would do 800 on a Kern. I'm just joking, Arthur.
The component didn't require the accuracy on a Kern. Now, the customer has bought 2 Kerns since then. He's got a Pyramid Nano, and he's got a Micro Vario with an external workpiece magazine. So he got switched on to what we were doing from a precision point of view. But previously, and the components are still being manufactured today, they're on Haas VF0 machines. So not sophisticated machines, but they do a really good job for this component, or this range of components. And the economy on the tooling is there for the customer as well.
Yeah. You mentioned that customer has a Pyramid Nano, and I think it's a very interesting chapter in the Kern machines. The Pyramid Nano came out 2004, I think.
Yeah.
What was it like suddenly having a large Kern machine?
Different and difficult.
Yeah, I mean, it was by far the most complex Kern machine also.
Yeah. But you get into crazy stories, and people would look at it and we don't want to spend that sort of money, we don't want to do this, we don't want to do that. But the accuracy on the part required serious investments. And we got to 2007, and it was the first time Rainford Precision organised a group trip of customers to come to Kern.
Okay.
But what we did was we made sure that each customer was only in their own marketplace. So we'd never bring 2 customers that were into tool making or 2 customers that were into subcontract machining. So each one had a different product, from electronics to watchmaking to tool making. So we were very careful on the mix of people that we brought. One of the customers was into tool making, came across, had a look at the machine, and then the following week he said, "Oh, we'd like to send some more people to Kern." And we said, "Oh, we're organising another group trip in 6 months." And he went, "No, I want him to come next week." And you're like, wow, yeah. Okay, so we hurriedly arranged for that customer to bring his tool makers over there to Kern. That was good. In the meantime, a second company had said, "Oh yeah, we're really interested, and we want to do different things." And we had a third customer. He was interested, but he couldn't get the budget.
Okay.
Blown out the water. And one of his problems was, whenever he got the budget, he had to have the machine delivered by the end of March of the following year. Otherwise, he lost his budget. So, yeah, it's one of the problems of sales. You live with it. Yeah. Anyway, we got to September, and the company that had been to Kern said, "Arthur, here's an order. We want a Pyramid Nano. We want the 3-axis. We want this number of tools, HSK 25 spindle." Absolutely fantastic. And before the week was out, a second company had said, "Yep, we want Kern. We're happy, but here's the order number." So that was good. Shipped that into information to Kern. Kern said, "Okay, we'll do the paperwork and we'll send an order confirmation back." That took another week or so, and then the customer said, "The machine's red." And we went, yes, that's what you've ordered. And he goes, "No, we don't want a red machine, because we're having a new building and we want our machines to be white and blue in a particular style." And it was like, okay, but the delivery that we promised you, which was going to be before the end of March, we're going to have to start the whole process off. And the first operation of a Kern is getting the castings painted. So it's going to put delivery back till May, June. And he said, "Not happy, but we'll go for the blue."
I actually know the customer. I think that color scheme is unique in the UK. I would say so. We're not going to mention any names, but yeah.
It was a UK customer, and I was just talking to the third customer and said, "By the way, I've had a customer with the machine on order. He's realised it's painted red and he wants a blue machine. This red machine for the cancelled order is going to be ready before the end of March." And within a day we had an order for a third machine. So literally over a few weeks we got orders for 3 Pyramid Nano, and that had been our record volume sales ever since, until last year, when we sold 5 micro HD, each one to a different customer. And that was good. That was enjoyable, because of the problems the customer had to solve in their manufacturing and the tolerances that they wanted to achieve. they've all bought the same machine, but they've all bought the machine for different reasons and for what it can do for their components. And that gives you a good feeling. You've been able to solve a problem and make life easier for the manufacturing customer. So, yeah.
Okay. We've spoken a lot about history, a lot about the machines, but Arthur, you're really a technical guy. And you told me before we started recording the podcast, you have two parts you want to talk about a little bit.
Yeah.
Well, unfortunately, in this podcast, we can't show pictures, so you need to describe them with words and metaphors, but I can upload some pictures to the announcement as well. But still, give it your best.
Okay. They're not particularly difficult forms. The first one is an aluminium block, and on the block, on 3 different faces, we mill steps, and the steps are 2 micron high. At 90 degrees to the steps, we start off milling a groove where it's 5 micron deep on the first groove, 3 micron on the second, 1 micron on the third, and the tool doesn't touch the 4th step.
Yeah.
That shows the control of the Z-axis is better than a micron. And it would be dead easy to make the 1 micron groove on the first step where there's no marks. That could blend. But it's proving that we are achieving better than 1 micron on our positional accuracy in the Z-axis. We brought a group of customers to Kern 2014, 2015, and we had something like 12 customers, and we were on the shop floor and had arranged for the applications team to do, we call this the step test. So we put a block of aluminium in the machine, and they machined it all over and produced these 2 micron steps and the 531 micron groove. And they're all looking at this part and said, oh yeah, that's really, really good. But in the meantime, the applications engineers had produced the second part. And what the customers didn't realise, that they were producing enough parts for everyone to take home and be able to show their colleagues what we produced. Now, simple machining, but from the first part to the last part, they could see the consistency. So everybody was very, very happy that we'd not only shown accuracy, but we'd shown consistency on achieving the accuracy. Yeah. So that was fantastic by the applications team.
And I mean, also very cool part because you can see the accuracy.
Yes.
I mean, if we manufacture a complex shape, you can maybe see a CMM protocol of that one, but you couldn't see the accuracy. And on that one, you can actually, just like by taking a look at it, see it. And it's a challenge you have on a lot of parts, like very precise grooves. For example, if you have like silicon injection molds where the flash out is real, there your gap tolerances in Z are like 2 microns. So it's actually, it has an application and you can see the tolerance. So it's a really cool part there.
Yeah, I like that part because it's one I can show. Whereas when I started with Kern, the sample parts we had were customer parts. And in the UK, probably 98% of our customers we have non-disclosure agreements with.
Yeah.
So you can't talk about the customer, you can't talk about the products, which is fine, not a problem. But how can you show accuracy to a customer?
Yeah.
This aluminium block with its simple machining was an ideal example of what you can do. And the other thing is, you can pull it out and you can say to a new customer, what do you think those steps are? How deep do you think that groove is? And they're talking 10, 20 micron. And then when you say, that groove there is only 1 micron deep. Feel it with your fingernail. This is what you're talking about on accuracy. And the customer's like, wow, yeah, we can achieve this. Well, if you got it right, yes, you can.
Yeah.
You know?
I mean, 2 microns is a nice staircase size for a bacteria. So it is a really small dimension.
Yeah.
I know this part, and when you look at it from like arm's length, it doesn't look like it has steps. It looks like just like a face milled part, but it actually is steps. So yeah, it's a very cool part.
But talking about 1 micron, about 6 years ago, we had one customer say, "Hey, we've got to achieve 1 micron," and they had Pyramid Nano, and they worked to find tolerances, but they'd never had to measure to 1 micron and prove it on their part. And they said, "We really, really need to achieve 1 micron. Help us." So we carried out an investigation in the machine shop, and we changed 10 things where the Pyramid Nano was. There was only one thing we changed actually on the machine, and that was from a water-soluble oil as the coolant to a mineral oil.
Yeah.
We didn't change anything else on the machine. The other things we changed, the air conditioning that they had, they said was accurate to 1 degree. We proved over 24 hours it was accurate to 4 degrees. So they had to spend money improving the air conditioning. That included re-insulating the ceiling of the workshop to maintain the temperature. That included building a false wall by the machine, because you would walk from the EDM department into the assembly department and everybody would walk past the Pyramid Nano.
Okay.
So now they have a false wall, and the only people that can go where the machines are the operator and the programmer. Even the managing director of the company can't go inside this segment. So they keep body heat away from the machines as well as an influence. And I say we changed one thing on the machine and 9 things actually in the environments to make it easy for them to achieve a 1 micron tolerance.
I mean, the Pyramid Nano, it's been on the market for now over 20 years, and it is still an amazing machine in 3-axis. If you do a 3-axis part, it is a viable machine. I would say one thing changed with the micro platform, and that is the successibility to the environment. Because what you said, that you had to change the air conditioning and put up a false wall, the Pyramid Nano is an awesome machine, and I enjoy seeing it at customers. We sadly don't have one here. Sometimes I would love to have one. But it is a fickle mistress. It is very dependent on the environment. I know a couple of Pyramid Nanos who are in like special climate chambers with less than 0.5 degrees of a Kelvin change over 24 hours, and they are most definitely the most precise milling machines on the planet. But with the HD, it's not as important. I mean, yes, you need air conditioning, but it can be 2-3 degrees. It doesn't need to be better than 1, because we made the whole machine a little bit more robust, a little bit easier for the operator to handle, which I think is a very good thing, because it shouldn't involve a year of studying the machine behavior if you want to pull off 1 micron tolerances. It should just be turn it on and make it. And we've gotten much closer with the HD or the micro platform overall to that.
Well, the hydrostatic guides, the volume of oil that you used on a Pyramid Nano compared to what you use on a micro HD is so different. It's so much smaller, and therefore the reservoir holding the oil is smaller. It's neater.
Yeah.
The Pyramid Nano machine, while it's got a bigger XYZ movement, is physically a big machine.
Yes.
It's a challenge. I'm in love with the Pyramid Nano.
Yeah.
I'm in love with the Micro HD, because seeing how customers can achieve their tolerances easily is key.
Yeah.
Yeah. You've just got to tell them how to do it properly. And I'll say I'm lucky in the UK. The operators on all the Kern machines are proud to be operating a Kern.
Yeah.
It gives a good feeling, and you know, when I speak to customers, and to be fair, I don't travel as much as I used to.
Mm-hmm.
The operators are saying, "Oh, I've done this, I've done that." It's a good feeling.
Okay.
Yeah.
Yeah. You also have a part with you, or a part you want to talk about, which is made on a micro series machine.
Yeah. What the other machine that, or the other machine part that I really enjoy, is the 5-axis machining of flat surfaces. It's about 50 mil by 50 mil.
Mm-hmm.
They've broken that down into 16 separate flats, and the part initially, the first flat, is milled in a standard 3-axis configuration with the tool moving in the x-axis.
Mm-hmm.
Then they will tilt the rotary axis, say 30 degrees, and machining the y-axis. Then they'll tilt the axis and rotate it and machine using the z-axis. And they'll use 16 different techniques of machining.
Mm-hmm.
And the thing that gets me is the flatness that we've achieved is less than 2.5 micron.
Yeah.
Even throwing the components over at crazy angles with the B and the C axes, and using either the X or the Y or the Z axis for machining, that's like, wow.
Yeah.
We're only milling a flat, but we've milled it flat to within 2.5 micron using 16 different techniques.
Mm-hmm.
And that's mind-blowing.
Yeah, it is.
And if a customer's going to machine and he's got to have some sort of relationship between different areas, that will give him confidence that we can achieve that. So I just love it.
Yeah.
Yeah.
It's two cool parts, which are, I wouldn't say easy to make, because it is a difficult part, but it's easy to make on our machine.
Yes.
And that's probably the difference. Yeah.
Yeah, it's easy on a Kern.
Yes.
Yeah. Yeah.
Okay. Ava, we're nearly up with our time. Usually this is the point in our podcast where I ask surprise questions of Simon, and he's fumbling around because he doesn't know what to answer. You also get a surprise question, but a different one. What's next? What's next for you? What's
next for me? That's a very good question. Very good question. I sold Rainford Precision because I was retiring 5 years ago.
Mm-hmm.
Then we had COVID strike, and I helped the new owner, I'll say survive. He might have survived without my help, but I wanted to make sure he did survive. He put a lot into it. And then projects just grew.
Mm-hmm.
Hence we sold 5 machines last year.
Yeah.
You know, very, very lucky. And I can see the growth of Kern in the UK and Ireland over the next couple of years being good for Kern.
Yes.
Whether I'm there or not, that depends on the number of people.
Mm-hmm.
Not only my wife, but also Simon and Sebastian, and also Miles, who owns Rainford Precision. Okay. So we'll see what the future holds.
Okay.
But the key element is my wife.
Okay.
Over the years, she's helped me solve so many problems even though she's not an engineer, she's been able to listen to me explain a customer's problem, and because I've had to break it down into simple terms, automatically it meant I've been able to think about what the solution is.
Okay.
So it's been very good that she's been patient and listened. Thank you.
Okay, Arthur, thank you very much for your time. This always feels, whenever you visit Kern, this kind of feels like another Arthur Turner farewell tour. I mean, 5 years ago when I was at Kern, you were like, yeah, this is your last visit. Then COVID came, you came back. So I hope this time it's not a farewell tour, but it's a see you again tour, maybe in another podcast episode or a machine project.
I hope so. I hope it's another machine sales project.
Yes.
We'll see. Thank you very much for your time. It's interesting. It's good listening to the podcasts because you can learn so much. And like I've just said about speaking to my wife Pauline, being able to break things down into easily defined segments, you can then solve the problem quite easily. So thank you.
Goodbye, Arthur.
Bye.